Hello and welcome. In this video, we will talk about two cases for the lines. If we have two lines, they could be parallel to each other, or they could be perpendicular to each other, or they could be neither. Now, what do we mean by parallel? Parallel, it will be similar to the situation. They will move in the same direction, but they will never meet. They will never intersect each other. It's like going in the parallel direction. Now, for perpendicular, they will meet, they will cross each other, but they will cross each other with 90 degree. This is very important. We will see it later for business application. But for now, when they meet, they will be a 90 degree angle between them. And this is, we call it perpendicular. Now, how do we know if they are parallel or not, or if they are perpendicular or not? In order to find out, you need to find the slope of the first one and the slope of the second one. If they are equal, it means they are parallel. Now, if you multiply them with each other, you get -1, it means they are perpendicular. Now, if it is not this case, and if it is not this case, it means they are not parallel nor perpendicular. So we call them neither. Let's see a couple of examples how we can check if they are parallel or perpendicular, and it also will give us more information on how we deal with equations of lines. Example number 7, determine whether the given lines are parallel or perpendicular or neither. So what we will need to do as a solution, we need to find the slope for each one. Well, the slope of M1, we find it, and we need to find the slope of M2, the green one and the orange one. Now, if we look at the orange one, first of all, we notice that y is alone in one side, so the number in front of x will be the slope. So the slope here is -5. And if we look at the green one, also the y is alone and the number in front of x is -5. Since M1 equal M2, the two lines are parallel. And that's what exactly we have here. Let's go to example number B, which we have an equation, but not in the slope-intercept form. I mean, for M2, that is easy because y is separated alone in one side, so the number in front of x is the slope. Now, for the orange line, I need to deal with it a little bit. I need to separate the y first. In order to separate the y, I will just keep 3y, move everything to the other side. So it will be -x -5. Next step, I will divide by 3. So I will get -1 over 3x, -5 over 3. And now I can directly find M1, which is -1 over 3. Now, are they parallel? They are not parallel. The reason is M1 is not equal M2. You can see M1 is a 3, M2 is a 3, M1 is -1 over 3. Are they perpendicular? We check if they are perpendicular. So we check if they are perpendicular. How do we check that? We multiply M1 with M2. So this equal to -1 over 3 times 3, and the answer is -1. So yes, these are perpendicular. And that's how we solve this question. Now we continue to the next example. Again, we find the slope M1, we find M2. Are they equal? Parallel. We multiply them. -1, perpendicular. If not this or that, we will just say they are neither parallel nor perpendicular. Let's see this example. This is a very, very nice example. Well, if we try to do the same thing as we did before, clearly m2 is equal to 0 because there is no x. It should be 0 times x. Now, if you look at this one has no y. So, x equal to a number, this has no slope because there is no y. I cannot separate y. And now, which line has no slope? It is the vertical line. So, we know that this line is vertical. Now, let's think about this line a little bit. This one here. Now, which line has 0 slope? It is not difficult to climb the line. It's not easy to go down in the line. It is a horizontal line. Now we have vertical line, we have horizontal line. What can we do next? Well, just think about it. Vertical line, it will look like this. Horizontal line, it will look like this. What happened here? Definitely there are 90 degrees. So they are perpendicular. Now we will go to example number 8, which we need to find the equation of the line passing through the point 3, 3 and perpendicular to the line 2x plus 3y minus 2. This is a very important example. The reason why it will collect whatever we did in this video and the one we did in the previous video. It has more than one idea. Now, remember, in order to find the equation of a line, we need two information. We need a slope and we need a point. The good news, I have the point. And the point is x1, 3, y1, 3. That's good news. So what we need to do first, we need first to find the slope of the line. Now, what do we know about the slope of the line? We know that this line is perpendicular to the orange line. So what is the relation between the two slopes? If they are perpendicular, it means my m, it means m1, which is my m, times m2, which is the orange one. The answer is -1. Do we know what is m2? Well, in order to know what is m2, we need to separate it here. So let me just deal with m2 here. So we have 2x plus 3y -2 equal to 0. So I will take everything to the other side, try to isolate y. I will get -2x plus 2, and then y alone will be -2 over 3x plus 2 over 3. So this will be my m2. So here we'll have m multiplied by -2 over 3 equal -1. Now, in order to find only m alone, we'll just have to divide everything by -2 over 3. So the final answer would be 3 over 2. Now, once we have the slope, we go to the equation y minus y1 equal mx minus x1. Remember, y1 was a 3, x1 was a 3, and the slope is 3 over 2. Which is, of course, we can just simplify it the way we like, or we just can keep it as is, as this is the final answer.